Good morning. Today we are working with a little bit different type of graphing than what we have in the past. In the past, we've always had a coordinate plane where we know how to plot points called rectangular coordinates. We know we move in the x direction and then we move in the y direction, we can plot points. Well, sometimes that coordinate system is not the best way to plot a point for some types of equations and for certain types of points. So the thing that we have developed is something called polar coordinates. Polar coordinates is more of a circular type graph. Think about this. Let's say that if I gave you an address in a city, you could go through the rectangular streets, the ones that are parallel, moving right and left, up and down, and work your way to an address. However, if you're a pilot in an airplane and you had to get from point A to point B, you're not going to have to fly according to those horizontal streets. Instead, what you would do is just fly straight from point A to point B. So that would be better on a circular type graph. We could start at the origin, we could travel a certain distance, and then whatever that angle would be. Well, we have a coordinate plane that is called polar coordinates. And when we plot a point, instead of xy, we have the ordered pair r theta. R is the radius, theta is the angle that is formed with the positive x-axis. Some of the things that we want to be able to do is use our equations that will be better in polar coordinates. Some will be better in rectangular coordinates. All of this will be developed when you get into the calculus. But for today, what we need to know is how do we switch from rectangular coordinates to polar coordinates and polar back to rectangular. So we're going to practice a few examples of that today. So let's get started. Let's look at one of the examples. This first type, we want to change a polar coordinate into rectangular coordinates. So we're given the ordered pair 6, 5 pi over 3. We have two equations that will help us change from polar into rectangular. The equation x equals r cosine theta, y equals r sine theta. So to be able to do this, let's convert this. So if we just use x is equal to r is 6, cosine theta is 5 pi over 3. Now you'll need your unit circle. Look up cosine 5 pi over 3. When we do that, cosine of 5 pi over 3, that is 1/2. Taking 6 times 1/2 gives us 3. We have the equation y equals r sine theta. So again, r is 6. Sine, our angle is 5 pi over 3. So again, take a look at your unit circle. Sine 5 pi over 3, that is negative radical 3 over 2. So that would give us that y is equal to negative 3 radical 3. So we would then write the ordered pair as 3, negative 3 radical 3. That would be our answer in rectangular coordinates. Let's do another example. In this example, we're trying to convert the polar coordinates 3, 2 pi over 3 into rectangular. So once again, we're going to use our formulas. X equals r, which is 3. Cosine angle is 2 pi over 3. Grab your unit circle. Cosine of 2 pi over 3. That one would be negative 1/2. Multiply this, we get x is negative 3/2. Let's convert our y coordinate. Our y coordinate is radius, which is 3. We use sine for our y coordinate, and again the angle is 2 pi over 3. When we look that one up, we get 3 times square root of 3 over 2. So that would give us, when we simplify, 3 radical 3 over 2. Write that as an ordered pair. Our ordered pair would be negative 3/2, 3 radical 3 over 2. Okay, let's do a couple other examples. In this example, we're now going to go backwards. Let's go from rectangular coordinates and change it into polar coordinates. So if we have the ordered pair negative 6, 0, my suggestion to find this in polar coordinates is plot this on a rectangular graph. So if you just plot the point negative 6, 0, that would put the point over here. Ask yourself, what angle would we have to travel to get to that point? And what you could see is that you can be able to travel from the 0 point all the way over to here. What angle would that be? What is our theta? And in this case, our theta would be pi. What is the distance from the radius, or from the origin out to this point? Well, that distance is a positive value. We have moved 6. So therefore, when we write this in polar coordinates, we have radius written first, our angle that we traveled written second, so the polar coordinates for this point would be 6 pi. Let's do another example. As we take a look at this example, we're in rectangular coordinates, point 0, 4. Plot that point. So we move 0, go up 4 units. Now, think about this. What would be the angle that we would have to travel? Start here from 0, and we travel up to where that point is located. That would be a rotation of pi over 2. Since that's pi over 2, we then ask ourselves, how far is that point from the origin? So we know it is 4 units from the origin. Therefore, can we write our ordered pair as 4 and pi over 2? And we would have our answer. Couple more examples. In this set of examples, we are going to be given a complex number, 3 plus radical 3i. We want to be able to convert it. So the first thing that we need to do is let's draw a picture. If we plotted the point, this complex number, the real number part is your x coordinate. The imaginary part is your y coordinate. So if you think about moving to the right 3 and up radical 3 over 3, you're going to have a point in the first quadrant. If you draw a reference triangle for this, the real part was 3, the imaginary part was square root of 3. What we really want to know is this radius. We need to know what is the angle and how far is it. So to convert this, to find that length of that, it's like finding the hypotenuse. So we have r squared equals x squared plus y squared. So r squared is equal to 3 squared plus square root of 3 squared. So r squared is equal to 9 plus 3. R squared is equal to 12. So r is plus or minus, when we take the square root, of 2 radical 3. Now, what angle have we moved? When we move this, we are given both the opposite and the adjacent. So from SOHCAHTOA, the opposite and adjacent tells us to use tangent. So we can write tangent of the angle is square root of 3 over 3. That's just inverse tangent. So let's find this. Tangent, where is tangent radical 3 over 3? And we can find that this one happens to be in the first quadrant at pi over 6. Now, what we want to be able to do, we are going to write our form like this. We start with r, which is 2 radical 3, multiplied by cosine of our angle, plus I sine of our angle. That's the way that we're going to be doing that on our delta math. We will have to fill in this number here, the angle, and this angle here. Those are the only ones that you'll be filling in. Okay, that's what we got to do for today. Let me know if you have questions.